In a real OpenAI engineering interview, a candidate with a published machine learning paper got cut in round 2. The question that ended it. Walk me through exactly what happens between pressing enter and the model returning the first token. 2 years of LLM experience, a published paper, gone. Most people can't answer that question cleanly. By the end of this lesson, you will. Every production failure in an LLM system, the wrong output, the runaway cost, the model that cuts off mid-sentence, lives somewhere in this pipeline. If you can't narrate it step by step, you can't debug it. And interviewers at Google, Anthropic, and OpenAI know that. Interviewers at Google and OpenAI use this to separate people who've read API docs from people who've actually thought about the architecture. So let's walk the pipeline. You type a prompt and hit enter. The first thing that happens is tokenization. Your string gets broken into tokens using byte pair encoding, BPE for short. GPT-4 uses a vocabulary called CL100K_base. It has exactly 100,277 tokens. That number is worth memorizing. Now you have a sequence of token IDs, just integers. But here's the step most candidates skip, and skipping it is what gets you cut. Each token ID gets looked up in an embedding table and it gets projected into a continuous vector, a list of floating point numbers. In GPT-4, that vector is approximately 1536 dimensions long. Cat stops being a number and becomes a point in space. If you skip this, the interviewer hears, I've used the API, but I haven't read the architecture. Now those vectors go into the transformer. And here's where interviewers probe hard. The moment you say the word transformer, expect this follow-up. Explain attention. Self-attention in one sentence. Every token looks at every other token in the context window and computes a weighted sum of their value vectors, where the weights come from how similar their query and key vectors are. That's it. Tokens vote on each other based on relevance, and the result is a new, richer representation of each token that's informed by everything around it. Why is attention O of n squared? Because the attention matrix is n by n. If your context window is 128,000 tokens, which GPT-4 supports, you're looking at a 128,000 by 128,000 matrix per layer per head. That's enormous. This is why long context models are expensive to run, and it's why a technique called flash attention exists. Mentioning flash attention unprompted is a strong senior signal. It shows you understand hardware constraints, tiling computation instead of materializing the full matrix. One more thing on attention. Don't say attention helps the model understand context. That's true, but vague. And vague gets you cut. Say this instead. Attention computes a dynamic weighted average over token representations. And those weights are learned, not fixed. Precision matters. After 120 transformer layers, you get a logit vector. One score for every token in the vocabulary. This is where sampling happens. Temperature. You've heard of it. Here's what it actually does. It divides every logit by the temperature value T before the softmax function is applied. Low temperature, say 0.2, sharpens the distribution. The highest probability tokens get even more of the probability mass. High temperature, say 1.5, flattens it. More tokens become plausible. GPT-4's API default is temperature equals 1, top P equals 1. Top P, also called nucleus sampling. Sort all tokens by probability from highest to lowest. Take the smallest set of tokens whose cumulative probability reaches your threshold, say 0.9, and only sample from that set. It adapts to the shape of the distribution in a way that top K, which just takes the K highest tokens regardless of probability mass, doesn't. Now here's the curveball interviewers throw. What happens if you set temperature equals 0 and top dash P equals 0.1 at the same time? Most candidates guess wrong. Temperature equals 0 collapses the distribution to argmax. The single highest probability token wins every time. That happens before top dash P is applied. So top dash P at 0.1 is irrelevant. You've already picked one token. Let's talk context windows and cost, because this is where production reality hits the interview room. GPT-4o costs $5 per million input tokens. If you have a 10,000 token system prompt and you're sending it 1,000 times a day, that's $50 a day just in prompt tokens before you've generated a single output token. Knowing that math live in an interview signals that you've shipped something real. The KV cache is why streaming feels fast. Instead of recomputing every previous token, their key and value vectors are cached. The heavy work is front-loaded. And here's a real benchmark you should know by name. The needle in a haystack evaluation, run by Arise AI in 2023. They hid a specific fact at different positions inside a 128,000 token document and tested whether GPT-4 could find it. Recall dropped below 60% for facts placed between 40 and 90% of the way through the document. The model lost track of information sitting in the middle of a long context. So when an interviewer asks how you design a long context system, the practitioner answer is, I don't rely on the model finding information in the middle of a 100,000 token context. I use retrieval augmented generation (RAG) to surface the relevant 2,000 or 3,000 tokens and keep the context window tight. The framework. State the mechanism precisely, name the failure mode it creates, and describe the mitigation. That's how you get to round 3. Recap: raw string to BP, token IDs to embedding lookup, attention weighted sums, logit sampling, decoded token. Repeat: lead with mechanism, close with mitigation. This Saturday's EtherStack AI quiz is 8 questions built exactly like a real Google ML interview screen. Token counting, context window limits, attention complexity, temperature versus TOPY, and the 3 most common mistakes candidates make when answering LLM mechanics questions. No hints, no multiple choice warm-up, just like the real thing. See you there.